Alright, so we're going to take a look at the team round. Now, in these competitions, when you do a team round, you typically have 4 students working together in any way they see fit. I've noticed that what seems to work really well is to break it apart into 2 different groups of 5 problems and have kids working in groups of 2 on those 5 problems together. And then if there's any extra time, trading off the answers with the other group of 2 so that you can get some double check work done. But obviously if you're working in groups of 2, you should be double checking as you go. So again, these problems are going to start out easy and get more difficult. If I take a look at number 11, the product of 7 and 2 is divided by the whole number difference of 7 and 2. What is the remainder? So a couple words of vocabulary that we need to know. First, product. Product means an answer to a multiplication problem. So this means that we're going to be doing 7 times 2. And then we are going to divide 7 times 2 by the whole number difference. Difference means subtraction of 7 and 2. And we want to know what the remainder is. So let's take a look at this. So 7 times 2 is 14. And we're going to divide 14 by 7 minus 2. 7 minus 2 is 10. Oh my gosh. I'm jumping ahead and doing the problem, doing the next step. 7 minus 2 is 5. So what is the remainder of 14 divided by 5? Well, the remainder is going to be 4. And we don't care really that 5 goes into 14 twice. And obviously 10 minus 4 is, or 14 minus 10 is 4. Sorry. Alright, how many counting numbers less than 50 are divisible by 3, but not 6? So again, a little vocabulary first. A counting number. A counting number is a number that you count. Not too surprising, like 1, 2, 3, 4, 5, 6, and so on. So those are our counting numbers. And so we need to have a counting number that is less than 50, but divisible by 3, but not 6. Well, if you think about it, that means that we are looking for numbers that are divisible by 3 that are odd, because any number that's divisible by 3 and divisible by 2 is going to be divisible by 6. So, first thing we're going to do is, well, there's a couple things we can do. How many times does 3 go into 50? Well, 3 goes into 50 16 times. So, what does that mean? That means that you have 3, 6, 9, and I can list them all out. And let's go ahead and do that, and then we can talk about faster ways. 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42, 45, and 48. So there are 16 different options, right? And how many of them are odd? Well, we have 2, 4, 6, 8. We have 8 different options, and there you have it. Now, going back to what I was doing here, you have 50 divided by 3, so there's 16 different options that satisfy, and you know half of them because all of the evens are going to be divisible by 6. You can just go ahead and divide that by 2. So I thought showing it this way, although slower, is a good way of understanding how or why this is the way it is. All right, number 13. If a certain whole number n is divided by 8, the result is the same as when 18 is divided by the same number, n. What is the number n? Okay, well, remember in that first video that I was saying that we want to show division as a fraction? Let's go ahead and do that. So when it says a whole number n is divided by 8, well, that just means n divided by 8. N over 8. The result is the same as when 18 is divided by the number. 18 divided by the number. And this says it's the same. That means they're equivalent. Now, you'll learn in 7th grade that this is called a ratio. Now, there are several ways to write a ratio, but what I do tell my 7th graders is whenever you see the word ratio, you should be immediately thinking fraction. You can always get away with writing a ratio as a fraction. So if you're immediately thinking fraction and you see the word ratio, you're going to be in good shape. So then, what's it called when you have two ratios that are equal to each other, like we have now? We have one ratio here. We have another ratio right here. So when you have two ratios that are set equal to each other, or two equivalent ratios, it's called a proportion. And there are a couple ways to figure out a proportion, and I'm going to show you the quickest way. And this is what I would do, it's what most of my students, I hope, would do. There is something called cross multiplication. We're going to multiply across the equal sign. So let's see what happens. 8 times 18. And that is going to equal, because we're dealing with an equal, n times n. Well, what is 18 times 8? Let's go ahead and do that. So 8 times 8 is 64, carry the 6. 8 times 1 is 8, plus 6 is 14. So we have 144 is equal to a number times itself, also known as n squared. Well, what number times itself is equal to 144? 12. So that means n must equal 12. Now, for those people who do know square roots, you'd end up with 144 is equal to n squared. What's the opposite of squaring? Square rooting. So you get square root, square root. What's the square root of 144? It's 12. Same thing. Now, why does cross multiplication work? Well, instead of showing you the why, I just want to show you that it does work. Let's find two fractions that we know are equivalent. Like, let's say 1/2, and let's say 1/2 is equal to 2/4. Everyone should know that, right? So let's do this cross multiplication and see what happens. 1 times 4, or let's start with the bottom, 2 times 2 is 4. And 1 times 4, 1 times 4, come on, right, is also 4. Oh, it checked out. Let's try another one. Henry, I have 2 more problems to go, so if you don't just want to set it there, that's fine.
If I couldn't really get it, I did maybe and I kept set it up, so I only got like the first 4 pages.
Okay, thank you very much. So let's try 2/3. I know that 2/3 is equal to, let's say 4/6. Cross multiply. 3 times 4 is going to be equal to 6 times 2. Oh, 12 is equal to 12. So I know this works, right? And so when you have a proportion, using cross multiplication is a method that will always work to find an unknown. All right, number 14. Emily has 3 times as many dimes as quarters and no other coins. If the total of these coins is $3.85, how many quarters does she have? I can think of 3 ways of doing this, and I will show you all 3 ways. I will start with the simplest way to understand, and then I will go to the most complicated way to understand. in the end, so talking about in middle school and high school, the more complicated way is going to work every time, and it will always take the same amount of time to do the problem. Whereas the easier ways to understand will take longer, the harder the problems get. But this one is not too hard. So I'm going to divide my board into 3 different sections. And so here's the first thing I can do. I can say that I have quarters and I have dimes. Let's make a little table. And this is a mathematical table. And I'm going to have my total here. Well, if I have 1 quarter and I have 3 times as many dimes as quarters, that means I have 3 dimes. Well, what is 25 cents plus 30 cents? Well, that's 55 cents, right? Easy enough, right? Well, if I have 2 quarters, that's 50 cents. But if I have 2 quarters, that means I have 6 dimes, so 6 times is 60 cents. That's a total of 1. Well, I'm not very close, right? So let's try another. Let's say I had, oh, I don't know, let's say I had 5 quarters. If I have 5 quarters, it means I have 15 dimes.
Oh my god!
So could you shut the door? So 5 quarters is going to be $1.25. 15 dimes is $1.50. And so that's going to get me a total of $2.75. I'm still ways off, right? But I noticed that 2 quarters could have 110, and I need 110 more cents to get there. So let's try 7. So I'm adding 2 more. 7 quarters. 7 times 25 cents. If I have 7 quarters, I have $1.75. Well, 7 times 3 is 21, so that is $2.10. $2.10 plus $1.75 is $3.85, and that's what I'm looking for, isn't it? So when it asks how many quarters does she need to have, she needs to have 7. So that's one way of doing it. Another way of doing it is to realize, oh look, every time I add a quarter, I'm going up by 55 cents. So I'm increasing by 55 cents. So that means for every quarter that I have, I'm going to increase the whole thing by 55 cents, right? So that means the number of quarters times 55 cents is going to equal $3.85. So I could just simply divide 385 by 55 cents. And obviously you'd have to move this over 2 spaces. So 55 going into 385. So that goes in, how many times does 55 go into, anyways. I have an 8th grader thinking about it right here. And now students are coming in here. Alright, so I'm going to cheat here because it's taking him so long. But I'm sure you at home could do better. So $3.85 divided by 55 cents. 7. He's a little embarrassed now.
No, but I got it right.
Oh, he got it right, but he didn't say the answer. Okay. Finally, the last way you could do this is to set a system of equations. And in the systems of equations, I don't even want to worry you with that right now. So let's just go with the 2 different ways of doing it. All right, the last problem on this video is going to be number 15. So, and it's not, this is a quick one. So if 3/4 of a number is 36, 3/4, let's write the number, of a number. So what am I doing with the number? I'm multiplying it, right? I'm multiplying it. 3/4 of a number times n is means equals 36. Then it goes on to say, what is 2/3 of that number? So we'll worry about this part in a moment. So what's the opposite of multiplying n by 3/4? In other words, if I'm multiplying n by 3/4, something times 3/4 is 36. What am I going to have to do with 3/4 and 36? Divide them, all right. So I have 36 divided by 3/4, And I'm sure you know by now to divide a fraction. What you're going to be doing is you're going to be taking that first number, nothing happens to it, and you're going to multiply the first number by the reciprocal of the second. The reciprocal of 3/4 is 4/3. All right, so let's go ahead and divide these. Now, it's much quicker if we reduce things first. So what goes into 36? So I'm cross-reducing. What goes into 36 and 3? 3 does. 3 goes into 3 once. How many times does 3 go into 36? 12 times. So 12 times 4 is 48. So the number is 48. But we're not done, because then it says what is 2/3 of that number. So that is one of your teammates' nasty behavior. Say you're sorry. As loud as you could burp. So of a number means we're going to multiply it. And so again, we're going to cross-reduce first. What goes into 48 and 3? 3. 3 goes into 3 once. 3 goes into 48. 16 times. 16 times 2 is 32. And there you have it.